ओके डियर फ्रेंड्स, प्रीवियस लेक्चर में આપણે ઇલસ્ટ્રેશન પૂરા કર્યા હતા. ત્યાર પછી હવે આપણે જોઈએ છીએ મિત્રો એનર્જી ઇન સિમ્પલ હાર્મોનિક મોશન. ઓકે, ઇન ટર્મ ઓફ પોટેન્શિયલ એન્ડ કાઇનેટિક એનર્જીસ. ઓકે, તો આપણે સ્ટડી કરીએ છીએ. ધીસ ઇઝ એનર્જી in SHM, simple harmonic motion. Okay, now we discuss about the potential energy. What is the potential energy? Okay, we discuss potential energy in term of displacement. Okay, now for the spring we know that this is potential energy, this is 1/2 kx square. Okay, this is the potential energy of spring. Generally the potential energy and relation between the force and potential energy, this is a F is equal to du by dx, that we studied in chapter number 6, work, energy and power. Okay, now du सब्जेक्ट बनाइए, dx सामने बाजू, this is minus f into dx. Take integration on both side, this is the integration du is equal to minus f into dx. Okay, f is equal to called a restoring force, f is equal to called restoring force. So this is u is equal to minus kx into dx. Now k बाहर काटना रखिए माइनस, दिस इज द इंटीग्रेशन x into dx. So x integration of x with respect to x, this is minus kx square by 2. Minus sign shows it is opposed to the external force. Okay, yes, and this is I can write it is minus sign આપણે ધ્યાનમાં ન રાખવી હોય તો પણ ચાલે. Okay, f is equal to already minus, here the minus signs because of this, and f is equal to minus kx, minus minus, here the plus, here the plus. Okay, let's see. Now at x is equal to 0, when we put x is equal to 0 at this time, u is equal to, so they say u 0. Put in this equation x is equal to 0, so u c is equal to u 0. Okay, so our equation u is equal to 1/2 kx square, put 0 is equal to, here the c, put c is equal to u 0, so this is u 0. So now u minus u 0 is equal to delta u is equal to 1/2 kx square. Okay, now x is equal to what? So x is equal to a sin omega t plus phi. Okay, so અહીંયા હું અહીંયા મૂકી દઉં. So this is a delta u is equal to 1/2 k a square sin square omega t plus phi. Okay, that's a very most important equation. એક આ equation યાદ રાખવાનું છે, એક આ equation યાદ. This is the equation in term of the sine, this is equation in term of the x. So we can say delta u is equal to periodically change with the time. Okay, with phase. The graph in term of the time. Okay, the graph of potential energy, this is very simple. Potential energy versus time નો ગ્રાફ આપણે જોવાનો છે. This is u versus t graph. Okay, so graph is just like that. Here the maximum value of potential. Okay, so graph is just like it is starts from the 0 because sign here. Okay, and this is the maximum value, and u max is equal to 1/2 k a square. Okay, what is the value of u maximum, and that we decide here. Once again I write the 1 half Ka square sine square omega t plus phi. Okay, for the maximum u maximum, sine square, sine and cosine term we take 1, so this is a 1 half Ka square. Okay, so this is a start from 0. Here I can say this is a t by 2, here the t, here the 3t by 4, here the t. Okay, from this graph, the conclusion of this graph, u potential energy is maximum at potential energy is a maximum at extreme point and minimum at a minimum, here the minimum, okay, at mean position. Okay, here we can see here the extreme point, here the extreme point, it is the maximum, and u maximum is equal to 1 half Ka square. Okay, and here u is the maximum for the extreme point here, and minimum for the here this is a t by 4, here t by 4, and here the t by 2. Okay, it means, what is the means of that? The u maximum at t by 4, 3t by 4 and 5t by 4, u minimum at 0, t by 2, t, 3t by 2. We can see from this graph. Okay, now we discuss about the kinetic energy. This is the most important, all the topics and all the formulas is most important for the potential energy. Okay, in SHM, the potential energy is parabolic function of the displacement. The potential energy minimum at the mean position, it is x is equal to 0, and maximum at extreme point x is equal to plus or minus a. Remember it, most important. Okay. Now we discuss about kinetic energy. Okay, kinetic energy. Okay, we know the kinetic energy K is equal to 1 half mv square. What is the equation? It is well known equation, 1 half mv square, and we can write 1 half mv is equal to omega square a square minus x square. This is a important equation. And now this is m omega square is equal to m omega square is equal to what? This is a k. આપણે આગળ જોઈ ગયા છે m omega square is equal to શું થશે? K. Okay, so this equation is equal to k is equal to spring constant. This is not a kinetic energy, spring constant, and this is, so put in this equation, so Ke is equal to 1 half K a square minus omega square. Okay, yes, so this is the equation of kinetic energy. Okay, and we put this here. So kinetic energy in term of the periodic function, so kinetic energy Ke 1 half m v is equal to a omega a square omega square cos square omega t plus 5. Okay, here plus or minus sign does not come. Okay, plus or minus sign આવશે નહીં. ઓકે, ચલો આગળ જઈએ આપણે. તો ગ્રાફ આપણે આનો આ રીતે જોઈ શકીએ છીએ. The graph is just like that. here the cos, so it is start from the extreme point, huh? Okay, so this is a 0, this is t by 4, this is t by 2, this is 3t by 4, this is t, and this one is t by 2, so this is a 3t by 2. Okay, okay, so from this graph we can say the kinetic energy is maximum, kinetic energy is maximum at 0, t by 2, t and 3t by 2. Okay, now kinetic energy, જો આ બધા પોઈન્ટ છે ને અહીંયા આ મિનિમમ વેલ્યુ છે, બરાબર, આ મિનિમમ વેલ્યુ તો 0 સ્ટાર્ટ નહીં થાય, બરાબર કે નહીં? ઓકે, આ બધી મિનિમમ વેલ્યુ છે, આ બધી મેક્સિમમ વેલ્યુ છે, બરાબર. કાઇનેટિક એનર્જી ઇઝ મિનિમમ at t by 2, t is equal to t by 4, 3t by 4 and 5t by 4. Okay, yes, and this we can say the another says it is the kinetic energy is inverted parabolic function of displacement, and kinetic energy is maximum at mean position. X is equal to 0 and maximum, sorry, this is a minimum at extreme point. Okay, this x is equal to plus or minus a. Okay, so this is the kinetic energy. Now we go further, total energy. What is the total energy? Okay, so this is very simple. Total energy okay, so discuss about the total, before discuss about total energy, I can say for the kinetic energy, what is the maximum value of kinetic energy? So once again I want to say, if we want to find out the maximum value of the kinetic energy, cos square omega t plus phi, it is, we assume, 1. Okay, so this is a kinetic energy is equal to 1/2 m a square omega square. This is the maximum kinetic energy. This is a maximum kinetic energy. Okay, so now we discuss about the total. Okay, total energy E is equal to kinetic energy plus potential energy. Very simple. What is the equation of kinetic energy? This is in term of the x, 1/2 m omega square. This is a square minus x square. What is the potential energy in term of the this is plus 1/2 m omega square kx square, but k is equal to m omega square. This is a x square. Now 1/2 m omega square x square, h square, x square, and this is the plus x square. So cancel it. So 1/2 m omega square a square. We can write k in term of m omega square. 1/2 k a square. This is E. E is equal to, this is called a total energy. E is equal to total energy. Okay, Now, from this equation, we can write total energy is always maximum and constant because K is constant, A is constant. Total energy always constant. Okay. Now, graph of total energy E versus T graph. This is just like that, and E versus X graph displacement. It is also just like that, and E max this value is 1/2 Ka square. Okay. Now હવે આપણે ગ્રાફ અહીંયા ડ્રો કરશું કમ્બાઇન ગ્રાફ. ઓકે, એનર્જી વર્સિસ ટાઈમ ગ્રાફ. પોટેન્શિયલ એનર્જી પણ આવી જશે અને કાઇનેટિક એનર્જી પણ આવી જશે. ઓકે, તો કાઇનેટિક એનર્જી છે કોસ, એટલે અહીંથી સ્ટાર્ટ થશે. ઇટ વિલ બી સ્ટાર્ટ ફ્રોમ હિયર. Okay, and potential energy start from here. Okay, and this is the line shows the kinetic and potential energy maximum. This is called E. E is equal to Ke maximum and Pe maximum. Okay, so very simple. Now important note, please write total energy of particle in simple harmonic motion is same at all instant, and all displacement, same at all time and displacement. Now the second note is a total energy depends upon mass, amplitude and frequency of vibration of particle executing simple harmonic motion. The total energy, it depends upon the mass, amplitude and frequency of vibration of particle that executing SHM. Okay, now we discuss about the average energy in SHM. Okay, now the I want to find out, first of all I will discuss kinetic energy. Okay, so this is kinetic energy, 1/2 m omega square a square cos square omega t. Okay, 1/2 m omega square a square તો constant એને આપણે એવરેજની બહાર લઈ લઈએ. Now average of cos square omega t, the mathematical step, the average of cos square theta, average of sin square theta, it is always 1/2. So this is the 1/2, 1/2 here, the 1/2, this is 1/4, it is m omega square a square, and this is 1/2 Ka square. So this is the maximum kinetic energy. Okay, this is the value of maximum kinetic energy. Now the average of potential energy, this is very simple, it is also 1/2 m omega square a square sin square theta omega t. So this is the 1/2 m omega square a square. Okay, so average of sin square omega t, this is the 1/4. It is also the maximum potential energy, and this, the summation of this is called a total energy TE, and it is also 1/2 K square. Okay, so this is the average energy in simple harmonic motion. Okay, yes. Now the very most golden key points, याद रखो, remember it. The frequency of oscillation of potential energy and kinetic energy is twice as that of displacement or the velocity or the acceleration of particle executing simple harmonic motion. શું કહે છે ફરીવાર? The frequency of oscillation of potential energy and kinetic energy, okay, એટલે frequency of oscillation of potential and kinetic energy is twice at that of the displacement, velocity, acceleration of particle executing simple harmonic motion. Second, frequency of total energy is zero. Frequency of total energy is zero because it remains constant. Yes. જો અહીંયા આને કોઈ ફ્રીક્વન્સી નથી હોતી, બરાબર કે નહીં? ધીસ ઇઝ નોટ ઓસિલેટિંગ, હા, ઇટ ઇઝ કોન્સ્ટન્ટ, સો ઇટ વિલ બી frequency of total energy is zero, but here the kinetic energy and potential energy frequency is twice that of the displacement, velocity and acceleration of particle executing simple harmonic motion. Okay. ઓકે ડિયર સ્ટુડન્ટ્સ, આટલા સુધી આપણે રાખીએ છીએ. નેક્સ્ટ ટાઈમ ફરીવાર મળશું. ગુડ બાય, ટેક કેર, થેન્ક યુ વેરી મચ. ફરીવાર મળ્યા.